Hello, my name is Magdalena Ponce de León and I work in the Medical University of Vienna. I will present simplified methods to estimate serotonin transported occupancy in a PET study with bolus plus infusion of DASB radiotracer. On the right, you can see the SERT binding potential after placebo or citalopram application. To estimate the occupancy, 2 intra-subject scans are needed, and also the gold standard reference uses arterial blood sampling, which is very uncomfortable for the patient. For this reason, we will try to estimate the occupancy either without the placebo scan or without the blood sampling. In this study, we used 2 PET scans with bolus plus constant infusion of DASB. We included 54 healthy controls and 37 patients with major depressive disorder, with mean age 24.42 years. After 70 minutes of tracer infusion, we applied 8 mg of citalopram or saline solution. We also took arterial blood samplings during the scan. On the right, we have the binding potential curves. The placebo is represented in blue, while the citalopram is in orange. We estimated these curves for high binding VOIs, caudate, putamen, and thalamus. Binding potentials were calculated with and without the arterial input function. That means BPP and BPND. The cerebellum was used as a reference. They were both estimated along 2 tracer equilibrium timeframes. The first one was between 60 and 70 minutes after tracer infusion. That is BPP and BPND 70, and it represents the values before the citalopram or placebo application. We also use from 125 to 155 minutes to obtain BPP and BPND 155. These represent values after citalopram or placebo application. To avoid interscan variability, mean values of placebo curves before the citalopram were matched to those of the citalopram curves. Occupancy was calculated as a relative decrease between placebo and citalopram scan, using BPP values estimated between 125 to 155 minutes. This is the gold standard reference. We also calculated the reference without the arterial input function. That means that we replace BPP by BPND in this formula. We proposed 2 methods which require only the citalopram scan. The first one uses BPP 70 of the citalopram scan instead of BPP 155 of the placebo. The same was done for BPND. This was possible as the radiotracer is already in equilibrium after 60 minutes. For the second one, we use 5-fold cross-validation to separate the data into 80% training and 20% testing. We average across training subjects the BPP and BPND placebo curves and then fit them with piecewise cubic interpolation. These curves were further scaled to match each testing citalopram curve before the drug challenge. This was repeated 5 times to predict all the BPP and BPND 155 of the placebo. This table summarizes what I described before. Both references use 2 scans, while the approaches proposed use only 1 scan. A refers to the use of BPP, while B uses BPND. We first compare both references. That will mean methods with versus without blood. We use Spearman-Persher correlations correcting for health condition. We found a high agreement between references with an R value equal to 0.77. We then compare methods 1A and 2A with reference A. All these were estimated with blood. The agreement in this case was also high. It was 0.78 for both comparisons. The comparison between methods 1B and 2B with reference B had the highest correlation value. It was 0.84 for both cases. All these were estimated without blood. And for the last comparison, we compare methods 1B and 2B with reference A. That means methods without blood compared to the gold standard. Correlations decrease in this case to 0.71 and 0.69, but they still remain high. We can conclude that both methods proposed to use a single scan show similar results, and all the occupancy values estimated were in good agreement with the gold standard. We finally suggest to calculate occupancies with method 1B. That means using BPND 70 of the citalopram scan instead of BPP 155 of the placebo. The reason for this is that it requires only one scan and the blood sampling is avoided. I would like to thank the whole neuroimaging lab and especially to Professor Lanzenberger and Professor Royescu for all the hard work to obtain these results. Thank you so much for listening.